Welcome to this tutorial class. Today we are going to be focusing on vector resolution. So we are going to see how we can resolve two vectors acting at a point to both vertical and horizontal direction. So this is a simple diagram that we have, and we need to start this way. So when you have this way, we have a force that is moving to the y direction, and we have another one that is moving to the x direction, and the angle formed between the two is just 90 degrees. So we draw a line from the center. We have this. This is all we have. So if two forces are acting, the resultant is from the center. So we call this guy the resultant force. We can simply refer to it as F, and here we can call this guy Fy, and here this becomes our Fx. So resolving this to the vertical component direction, we have vertical component. First of all, we need to work around completing this guy here. So here we can lift this guy to this point and call this guy our Fy, and here becomes what? Our Fx. So if we drag this triangle out to this point, we are going to be having something of this nature. Now an angle is going to be formed at this point, the same way that we have it here. So if this becomes our Fy, and here becomes our Fx, here becomes the resultant force. So now recall that sine theta is equal to Fy over F, which is equal to opposite from sine theta equal to Fy over F. We have Fy to be equal to F sine theta. If we multiply F by this sine theta, we are going to have something of this nature. So we call this one our equation 1, which automatically becomes the vertical component of the vector resolution. Now, horizontal component, we have cos theta is equal to adjacent over what? Hypotenuse. And our adjacent is giving us f of x. Our adjacent is f of x. Our adjacent is f of x. Is f of x over the hypotenuse. So from here, automatically it means that f of x is equal to f cos theta. So this is what we have in our equation 2. So from this point, therefore, vertical component is giving us f of y is equal to f sine theta, and then horizontal component is giving us f of x is equal to f cos theta. So these are the two basic things that we are having here. So now how do we get the direction of the resultant? Now to be able to get the direction of the resultant, we need, from here, I'm going to redraw this diagram. I'm going to redraw this diagram. We still have this diagram this way. We still have this diagram this way. Here becomes the angle. Recall that we have this to be what? Our Fy, which is equal to F sine theta. And here becomes our Fx, which is equal to F cos theta. Now, using the direction is giving us note that tan theta is equal to sine theta over what? Cos theta from trig identity. From trig identity. So that tan theta is equal to tan theta now becomes the value of sin theta that we have here. From here, we can say that sin theta is equal to Fy divided by F. And here we can also say that cos theta is equal to Fx over F. So putting this into this particular formula here, we are going to be having Fy over F divided by Fx over F. So if these two F cancels out each other, we are going to be having Fy over F multiplied by F over what? Fx. So this will now cancel out the second one. These two F cancel out, and then we are going to be having Fy over Fx. So therefore, the direction of the resultant tan theta is equal to Fy over Fx. So here we can simply push forward to say that theta, if tan theta is equal to Fy over Fx, we can simply say that tan or theta is equal to what? The tan inverse of what? Fy over Fx. This becomes what we are looking for as the angle between Fx and Fy. So this is what we have. Finding the resultant force F, between Fy and Fx. So we have from here, recall this diagram again. This theta, this F, and we have this guy to be Fy, and then this is our Fx. So from here, we can simply put that using Pythagoras theorem, we can have F squared, which is the resultant, to be equal to what? Fy squared plus Fx squared. So here F resultant is simply equal to the square root of the summation of this plus this. Alright, so this automatically becomes the resultant force. So in summary, In summary, from here is Fy and this is Fx. In summary, we said vertical components, we have Fy equal to F sin theta. Horizontal components, we have Fx to be equal to what? F cos theta. Resultant vector, we have F subscript r to be equal to the square root of Fy squared plus Fx squared. Then the direction of the resultant force is theta equal to what? Tan inverse of what? Fy over Fx. So this is what we have basically on this aspect.